Good afternoon. This is that talk. We've only got a couple people here, so we're just gonna keep this lighthearted. So just before we begin, just to kind of get an idea of where people are. How many people in this room happen to be like full-time Scala developers or even part-time Scala developers? Any? All right, 2 guys. Strange that you would attend this talk. Great. Everybody else, kind of enterprise security, consulting, things like that. Is that any other tangential relationship to Scala besides I'm a developer of it, or some sort of interest in assessing or understanding its place in enterprise? No. All right. Yep. Yeah. Exactly. Right. And that's what we're all about here. Is it up? Where'd it go?
Like blinked off.
What? Okay. It worked before. Here. Let's try. Okay, once it goes full screen, just leave it.
Okay. Yes.
Okay, cool. All right, let's try that again. So yeah, let's go next. Who are we? I am Erik Cabetas. I help run a small security team out of New York City called Include Security. Basically got together a bunch of my old hacker buddies from Capture the Flag contests from back in the day and veteran penetration testers, and we hack applications, mostly for Silicon Valley and New York City companies. Paolo.
Hi, I'm just a general hacker, Android. I work on Android and do other cool things.
Yeah. So Paolo has done the grand majority of this research. I'm just kind of helping present it. Also, we had 2 interns help us out with the code that we'll be covering at the end. So one of them, Samuel, thank you very much. And then the other was a guy named Stuart out of middle of nowhere, Michigan. Okay, so yeah, okay. Some slides got removed. So what are we doing with Scala here? So Scala is essentially...
So Scala is this sort of a functional and object-oriented, lots of other sort of paradigm language. The main point about it is it compiles down to Java bytecode, executes on the JVM, so it's kind of neat when you already have an existing infrastructure based on the JVM. The web apps, they're in a service container just like in Java EE, and you've got all the same kind of basic problems there. One of the main things that they tout about Scala, it's got really strong typing, as well as all the functional stuff it has. But you have to use the type system correctly. But if you do, it can catch some errors.
Yeah, and historically, Scala is about 10 years old, but the web frameworks are still pretty immature. It reminds me of Java in the early to mid 2000s with like kind of struts 1 kind of thing. So they're still just as they're creating the frameworks, they're like, oh yeah, we also need to throw that in and throw that in. So they're still not quite totally mature, but they're still pretty good for where they are. So what does Scala in web applications look like? So here's an example play app, just a very basic Hello World one. So on the top, you've got what the view looks like. You've got the @ references to show where the variables are in the view layer, and you have a route that essentially maps a type to a class, and the typing there really helps out a lot from security. Obviously, in other languages, PHP or what have you, you're going to have to take in the input from the GET request, cast it as an int, if you remember to cast it as an int, come up with effective coding policies and patterns to ensure that that's always what you do and that everybody adheres to it. With this, it's much simpler. You can define types and set validators for types. It's pretty nice. Yeah, when you're creating a play app, for example, it has kind of some auto generation type of things, very similar to how when you create a Ruby on Rails app, it's got a whole directory structure. All right, this is the problem. These two were switched. Okay, so you guys, we're hoping that you guys are mostly penetration testers, Scala devs, and what you're getting out of this are the coverage of the 4 topics, right? So we're just briefly going to go over like what Scala app stack is, and we've actually just gone over that. So that's that. Then we're going to go over the OWASP top 10, and the main thing here is in the white paper that we created for this talk is just a bunch of patterns and anti-patterns, right? So here's the good thing that you do. Here's the bad behavior. Here's the good behavior. And going through all of that. So this is really, ideally, I could see this as, hey, I'm a penetration tester, and I'm about to do an app that's Scala. I've never done a Scala app before. What are the patterns I'm looking for? What things do I need to semantically look for in the code, look for in the config files, stuff like that. The white paper has a lot more of these, just all these good patterns, all these bad patterns. We can't obviously go over all of them in the talk, so we're just going to hit some of the more interesting ones. And then we have two pieces of code, or coding projects, I should say, that we're going to release probably tomorrow. We'll just do a quick demo of them today. All right, so we're just going to dive into OWASP top 10 stuff. For those who are intimately familiar with the OWASP top 10, just kind of nod, like pretend you haven't heard this stuff before. For everybody else, this may be a little bit of new information.
Okay, so LiftWeb's got this ORM layer called mapper, and the nice thing about it is if you use it properly, if you use the API that they want you to use, it converts your queries directly into parameterized queries. There are some gotchas because they made it very flexible for developers. So don't use the in raw or the parts of the API that use in raw. And to check for this, there's a parameter that things with in raw takes called I have validated this SQL. It doesn't actually check anything. It's just kind of sort of a on-faith thing for developers to say, yeah, I've actually validated this SQL.
So this is kind of funny. So parameterized queries, you guys know, prevent SQL injection, right? So dynamic queries, raw queries, that's where you could have SQL injection problems. So the developers of the LiftWeb framework said, okay, well, every time we're going to have some sort of raw SQL query, how about somebody signs off on it? Kind of like OpenBSD, 2 people have to check on everything that gets checked in. So they created this. I have validated this SQL, and you have to literally put your name on it to say that you have looked at this SQL and that it's okay. So if you're auditing a Lyft app, I would just grep for that and look to see all the places where that guy has done raw SQL, and perhaps he just put his name there or her name there and did not validate the SQL. And more often than not, that's the case. Because folks are going to do this when they think that parameterized queries are preventing them from doing things like highly dynamic where chains, where clause chains, and things like that. All right, here's a couple other gotchas in LiftWeb's SQL layer. And by the way, this is small here. Let's just throw hands up, speak out if you have questions. We want to make it a discussion and cover the topics and the things that you guys are interested in. So here's some other gotchas, right? So you've got various unsafe functions and object calls. Not all of these have that little parameter we talked about. So if you if you're just doing kind of a semantic analysis of code, these are the sinks that you're looking for. You're looking for calls to these guys and looking for those parameters within those method calls and object instantiations. And then on the right, we've got the safer options, the more correct way of doing it that won't bite you in the butt for SQLi. Anything there? No. All right. Cool.
Okay, so in Scala Play, which is the other framework, they have the inorm or inorm ORM, which also takes the queries and turns them into parameterized queries. But you can also do raw string formatting and bypass all the checks for this feature. They let developers basically, have whatever the versatility they want. So if you notice on this pattern down here, I'm just taking a Scala string and I'm putting in parameters into the first %s in that ID, and just grabbing them and shoving them in there, and that will of course allow a SQL injection.
Yeah, and I noticed that we just kind of jumped in without addressing the frameworks as a whole. So obviously, there's multiple frameworks for every language. In Scala's case, the two most popular are Lift and Play. So that's why we're here covering these two. As far as the future goes, we found that Play seems to be more popular, and Lift seems to be being maintained less and less. And we'll cover towards the end kind of where they compare against each other. But I wouldn't be surprised if 2 years from now, like, everyone's doing Play and not many people are doing Lift, because just the amount of developer activity we saw on the projects has just decreased in the last year and a half on Lift and increased significantly on Play. So just a little context for those of you that don't do these kinds of frameworks in your day-to-day. But yeah, so when talking about SQL injection in particular, these ORM layers that Anorm and what was the other one? Mapper are basically your go-to ways of doing this. You can not use an ORM layer and do raw SQL yourself. You're going to shoot yourself in the foot every time. You're going to forget to validate input. You're not going to match single quotes up. Use the ORM layers. They're there to be safe and to help you. All right. So on other topics of injection, besides SQL injection, so just like any other language, you have data flows in the web app, right? So you can have command injection, XPath injection, LDAP injection, et cetera. Luckily for the penetration tester, security auditor, what have you, it's pretty simple to find these. You're just going to grep through looking for imports of process, and then similar to PHP or Perl, how they have backticks to execute commands as you go through. These guys have this exclamation mark. So it's really small and you might miss it if you're just casually browsing the code, but you have to know what to look for. You have to look for that import to process and then also the exclamation mark. So, go ahead.
So Lift is kind of nice and has a bunch of features already baked in, simply because it seems to be more of an enterprise-oriented sort of framework, and it's got these a bunch of classes called into the mega proto user naming scheme, and they're already built in, and you can use them, and they will store names, emails, passwords, and do user management for you. So basically, one thing to keep in mind is that you can shoot yourself in the foot if you go out of your way, which is to say, in this particular case, there's a line in proto.user.scala. If you change this destroy session on login to false, you're not going to be renewing the sessions on successful login. So you could get session fixation that way. So a good pattern to look for in the code base is to see if they're actually using the MegaProto user API, just by seeing if their regular classes for their users are inheriting it.
Cool. And also in Play, Play doesn't handle users as much as Lift does. Lift actually tries to handle a lot more things for you than Play does. So from that perspective, Lift kind of controls user management a lot more than Play does. And the Lift guys really espouse that as a feature. They go on and on about how you don't have to worry about this stuff. And to some degree, you don't, and it makes it pretty nice. I would love to see Play have more of that stuff available. Okay, so Play, though, does have this interesting thing with the session cookies, right? So very similar to on ASP.NET, how you have the view state and various other kind of MVC frameworks. In Play, they have these session cookies. they have an application secret on the configuration file application.conf. And that secret kind of does the signing with it.
It's signed with it.
So they'll do HMAC signing on that. By default, there's no session timeouts, so something to look out for there. The two types of cookies.
We've got two types of cookies, the session cookie and a flash cookie. The flash has nothing to do with Adobe. It basically means it's supposed to be a temporary value from a calculation, and it's supposed to hang out temporarily. The key thing is that the flash cookies are not signed at all, so the user can tamper them. So don't put access levels or important state in the flash cookies.
Yeah, so a little different from how ASP.NET has HMAC validation there. So there's some good patterns of how to use that at the bottom. All right, so getting on to cross-site scripting, everybody's favorite thing. So Lift and Play actually do this pretty well. And I think you're seeing kind of a theme here. They, by default, do have pretty good patterns for security. There are a lot of gotchas, and we'll even show you. So a couple people have left. For the people remaining, in a couple slides, we'll have one build configuration kind of zero-day thing that we'll go over that we reported today. So we'll go over that in Activator in a couple slides. But back to this, cross-site scripting. So in Lift, they really get the notion of view first. You're supposed to keep everything on the view completely separate from any logic whatsoever. And when you're doing that kind of stuff, Lift has this notion of, what's the DOM rendering stuff? Is there a name for that? The DOM rendering thing that it does? It keeps, on the server side, it keeps a whole instance of the DOM so that it can generate it and then just push it out all at once. And that's really awesome because if you have that whole thing there, then you can analyze it and prevent things like cross-site scripting for the most part. So that makes it really nice from a patterns perspective. All you have to do is keep your view exactly how they tell you, and you'll just never have a cross-site scripting problem. Did I miss anything there?
Yep.
No. All right, so what does this look like? On the top, you have a LiftWeb template. So it's kind of have these XML nodes, tags, what have you. And then here's the server-side code that spits it out. So, and then what you get is on the bottom, this gets rendered to the screen. It doesn't get executed, it gets rendered. It's just naturally encoded as part of it. So as part of the types there, it's just all gets naturally encoded. In Play, they use
the template they call the twirl template. It escapes, uses HTML escapes for input by default. But they, again, want to make this flexible, which is a key thing in both these frameworks, where if you actually look, there's two ways to actually turn off the escaping. And one of them is you can turn it off in the template. So this is the template code right here. And it, as you can see, it takes in a message from the user, and it displays it via this HTML template directive. This turns off the escaping. So if you have any message that comes in here that's got malicious input, it will just get
easy thing to do if you're auditing a Play app is just grep through for that. So grep-r at HTML through your whole view layer and find where they screwed up. And then also from the defensive side, if Play is part of your SDLC, it's really easy to just do a check-in hook or maybe a nightly run and just do a basic semantic analysis. You've got your set of at HTMLs that you know are safe, and then you just have it alert to you every night when there's something that you know is not safe. And that way you can sleep well at night knowing that the ones you've signed off on are good, and then anything on the nightly semantic analysis, it'll kick out to you, so you can sleep well at night, that you won't have cross-site scripting problems. There is another way to screw it up, though, that you can also check for.
So yeah, this is the other way. This is actually screwing up in the code. So regardless of the template, if you go ahead and output things as text HTML. They won't use the template system and just go ahead and spit stuff out to the browser.
Yeah, so stick to the Torl templating. You might want to do this if you're just like pushing out raw bytes for a download or streaming something in real time. So there's definitely a need for this, and that's why it's there. So you can also grep for this kind of pattern. Look for as and see what kind of MIME types they're outputting.
So the good pattern down here is actually using the type system for you. It's an example of using the type system for you. So you've got an endpoint here called bank account, and it takes in a number. And this one, Scala will let you, or Play will let you specify the type for that parameter, which is an int. So the upside to this is if someone tries to do, say, a SQL injection or SQL injection into that parameter, or
cross-site scripting.
Or cross-site scripting.
Yeah. Whatever. You're covered.
Yeah.
So that's
it'll throw an error up.
Okay. Moving on. Insecure direct object references. Very, very straightforward here. It's just like pretty much every other language. You have your standard sources and your sinks. I'm talking ahead of myself. Play does have one feature that makes this kind of stuff easier. But both on Lift and Play, you have pretty standard problems with direct object references. In Play, though, they have the concept of security traits, which are pretty cool. So security traits are kind of like typing your execution of code. So you can say, all right, this code here, it has to have this trait, and you can define traits dynamically. And then once you define a trait for a scenario, it's just always an effect for that scenario. So I can say, all right, every time I access this object or something, this trait has to be here. And the trait is checking for a user role or something of that nature. So traits in Play make authorization checks a lot easier, which help for preventing things like this, right? So there's no... presuming that user input here in the bad pattern is an int, there's no SQL injection there, but you can still have a direct object reference and access other accounts. But once you create a security trait for the account owner, then you tie that to the access of that object, and you're good. You still have to create the traits properly, right? If you don't do the checks in the traits right, then the traits aren't doing anything to help you. All right, moving on to misconfiguration. So when you turn both these things on, they're kind of in developer mode, and there's lots of verbose error messages. They give you, in certain cases, they give you stack traces. This screenshot's too small, but basically what it's doing there is we're trying to do a cross-site script on a route. And it's expecting an integer, and it's just spitting out like, hey, that route's no good, but here's all the other routes. Why don't you just try any of these other routes? And here's the types that they're all expecting. Why don't you just try all the types and all the routes? Go for it. All right. Okay. So, yeah, there's short time.
Okay. So basically, there's one of the key things.
All right, I got this one. All right. Play uses for their main configuration file something called application.conf. It's made by the Play company is called TypeSafe Inc. And they have this format, which is kind of a human-oriented format. So you can do JSON, properties file, or however you want to basically make hierarchical notations in a config file. You can stick it in there. One of the important items in this config file is an application.secret, which if you leave it in there, it stays static. So when you restart the app, it's always going to be the same thing. So if you ever release open source code, I don't know, like if you're Heroku making Dev Center Java Play, you don't want to embed an application secret in there. You want to have the user create it dynamically. Or else you end up with this, which is what people deploy when they're trying to use Play to connect to Amazon S3 through Heroku that has a static application secret. So now you know everybody's application secret unless the developer goes and changes the app secret, which they're not going to do because they forget or they just don't consider that as they're grabbing this library to use in their app. So something interesting to think about is looking through the dependencies of your app and saying, all right, what open source dependencies are there, and what problems do I have in those dependencies, like hard-coded configuration secrets and things like that. So yeah, I guess that's a 0 day or something. Like you can just get on GitHub, search for application.secret in Scala files or in Scala projects, and you'll find other people's hard-coded application secrets, companies that push out code like that. Okay. In Lift, the main config file is called boot Scala. All right, whatever. Yeah, so Lift, the default environment on Lift is developer mode. They also have a test mode. When you're in developer mode or test mode, everything is available. Nice. So everything is available, meaning it gives you full error messages, full stack traces. What was the other things that it does in developer mode?
Sitemap, it lists the sitemap and it puts the comments out there.
So sitemap is not just kind of a routing layer. A sitemap in Lift is basically your kind of a full ACL layer, access control layer, that defines all the ways somebody can access URLs in your Lift app. And that can get very simple, such as if they hit this URL, like in a route style, then great. Then they access this URL. Or it can get very complex, saying if they have this role, if it's between this time and all these other constraints, then allow that in there. So on Lift, it's a very, very strong authorization system. And disabling that authorization system weakens the app. So definitely look in the boot Scala file and see if they disabled sitemap. Because if they did, they're going to screw up a lot, because sitemap gives them a lot. Yeah. Oh, the other thing is well, we haven't talked about we'll cover the CSRF goods in a sec, but it helps. Lift by default protects against CSRF. If you deploy anything in test or developer mode, it's going to stop that protection. So basically, never deploy in test or developer mode. Make sure your DevOps people ensure that it's impossible to ever deploy something on the internet in test or developer mode. Because if you leave it open, you're going to get screwed.
So one of the nice things, if you use the default APIs for handling users in Lift, is Lift stores the passwords being entered into the database via bcrypt. And what it does is it goes, okay, well, you're registering a new user, here's the password, okay, I'm going to bcrypt that, and I'm going to prepend a B semicolon to that, store that in the database. One of the things, though, is that Lift does check to see when it pulls passwords out of the database. If it doesn't start with a B semicolon, it's going to assume that's a SHA-1 hash, and it's going to treat it like so. So basically, in older systems, you might see SHA-1 hash passwords instead of bcrypt.
Yeah, that's your main takeaway. Is if you're auditing an older Lift app, look in the password hashes. If it's not a black box, if it's a gray box, and just check if they have the old hashes or the new hashes. If they have the old hashes, see if you can get them to migrate their users. Cool things. The Lift guys are a lot more proactive about security, and they really think about it a lot more than anybody else in the Scala community. So one thing they're thinking about is sensitive data in your app. Right, so you have credit cards coming in, you have PHI and PII and things like that. What about a filtering layer that automatically looks for that sensitive data and either nullifies it or sanitizes it in some manner? So that's something they're adding to the next version of Lift version 3. Then they also have this object lifestyle callback mechanism where almost like a triggering-like fashion, like when you access this object or when you modify this object, you can register callbacks. So for that, you can do kind of column level and row level encryption in databases. Play says, forget that stuff, you guys deal with it. All right, so knock it up.
Okay, so basically, the sitemap for Lift, it's kind of really complex, but the takeaway from it is that you can set really, really fine-grained access rules. You can say, oh yeah, this person requires to be logged in, they have this authentication role, and it's between this time of day and that other.
Yeah, I mentioned that already.
Yeah. So,
What about the partial functions?
Yeah. So basically, yeah, the developers go ahead and they write the logic for mapping the requests to the resources via partial functions. And basically, you can just think of them as callbacks, and they're all stuck in this giant, just think of it as a queue. And whenever something comes up, a request comes up, they look through this queue and say, who handles that? And if it's not handled, it's not served up. So it's effectively kind of like a whitelist.
Cool. All right.
Yeah, Play doesn't have that, but
yeah, Play's not down with the authorization layers. They kind of let you besides the security traits. They don't really have a full-featured authorization layer that's anything like the sitemap that's built in. Sitemap kind of does more for you. Play with the security traits gives you more expressiveness and lets you do more. There's this thing called deadbolt, which everyone's moving to, that kind of is a more full-featured thing, closer to sitemap. So deadbolt is like a third-party thing. It's not part of Play itself. All right, so cross-site request forgery.
So one of the things that happens as an effect of the way Lift is engineered is that all the form elements, the names and such, get replaced by these GUIDs. And the GUIDs change per session basis. And, well, and the part of them at the end, the parts here, I don't know if you can see that aren't highlighted, those actually change within the session.
So when we say GUID, we just mean like what the format looks like. It's not really a GUID in like Microsoft world is a fully random number that's usually like 128 bits random number or something like that. So we're not talking a fully random number. Some of it is randomized. So the highlighted yellow part is the randomized part?
Yeah, that's the one based on session.
Okay. So half of it is based on your session, and I think 30 bits of it is based on this particular request. And that's built into how Lift operates. So it kind of takes the whole DOM rendering layer away from you. And as part of that, they added this randomization into the inputs. When they take that layer away from you, they actually give you something, which is this cross-site request forgery protection. And that's just built into all Lift apps, which is pretty nice. So yeah, short of some sort of cross-site scripting combination attack, and short of them screwing up with the random number generator, you're going to be covered with CSRF on the Lift app. On Play,
so Play has anti-CSRF as well. The takeaway from here is to make sure that's turned on. There's two ways you can do it. You can do it globally, which is this wrapper in the twirl template that ensures the CSRF token value is added to requests. Or you can use the libraries that call CSRF check and CSRF add token whenever you get to whenever an endpoint is being executed.
So really simple, just grep through if you're auditing an app, a Play app, grep through, find these things, and you'll find where they're doing it correctly or incorrectly. All right, this is the fun thing. Both Play and Lift basically leave all components dependencies up to you. The common build systems are SBT, Scala build tool, and Activator. So one of Include security researchers, he was doing a bunch of Clojure research, and he found that the Clojure build tool would pull all of its dependencies, the jar files. It would just pull it over HTTP. So it would go out to Sonatype or Maven.org or whatever and pull all of the jar files over HTTP. But wait. It also pulled the SHA-1 and the MD5 hashes. Oh, okay, great. So they're checking SHA-1 and MD5s. But yes, but it's all over HTTP. So all you have to do is man in the middle the jar and the SHA-1 hash. It's literally called SHA-1.txt. Man in the middle both of them, and you just give them the SHA-1 text file for your SHA-1 of your backdoor jar file. So we created a proof of concept of this and had it running. So if anybody on your local network was running Scala build, this was the one we wrote the proof of concept for was for Clojure. If anyone was running the Clojure build tool on a local network, it would ARP man in the middle and run a jar file on your system as it's compiling. We found the same kinds of problems also existed in SBT and Activator in Scala world. So SBT Both, and I do give these projects credit. SBT and Activator both actively at the same time that the closure thing was released by Max Weitzman. They both actively said, guys, we should take a look at this in our tool. SBT went through and took all the HTTP away from their whole tool. So now it's HTTPS. So great, SBT got it right. Activator tried to do that, but they did not get everywhere. So we found many instances where they're pulling templates, where they're pulling IV configs, and IV configs, if you can control an IV config, you can control the box essentially during the build. So the IV configs, the templates, and also some jars, they still pull down over HTTP. So they tried to fix it. They didn't quite get it. And so this morning we reported it again to them. So hopefully now they'll fix it right. So yeah, if you guys have Activator, look out for that patch. For the 2 Scala devs, please tell the Scala people. Look out for that upcoming patch. Hopefully they'll get this problem like completely eliminated from Scala world. Bad patterns and good patterns. Pretty simple. In your SBT, which is your Scala build tool config file, just use HTTPS. Now, another bad pattern I should mention is disabling SSL checks. So you can screw this up royally if you, and people do this. If you have, so I've seen a developer do this when they have kind of a system that does man-in-the-middle checking at the corporate layer for all SSL certs. So they kind of man-in-the-middle everything. And Blue Coat used to do this. You would man in the middle all the SSL certs, and then they would monitor all your traffic. So sometimes if you have that sort of system in place, people will just say, oh, I'm getting lots of certificate errors on my builds. I'm just going to disable all SSL cert checking. So never do that.
Okay, so with Lift you can do redirects, and the way that you do redirects is via the redirect to API call. So the key thing about this is don't allow direct user input to go into this. You always want to have a static route, or you want to have some sort of whitelist here to make sure that you're only redirecting the things you actually want to. Otherwise, they can go ahead and redirect it to any external URL. This was actually added in the earlier version of Lift when they complained that you couldn't redirect externally. So they decided to say that if you put in a protocol in the redirect target, you can go out externally.
Okay. And then in play, there's more ways to shoot yourself in the foot in play. But the main way is just doing the redirect. Wait, am I thinking about the wrong thing? No. Oh, we did. Oh no, they're okay. They're all there. Sorry. So the main way to shoot yourself in the foot is to let user controllable input get to the redirect. If they control the base schema and the site, then you can use that. There's lots of redirect attacks. It could help attack OAuth. The basic attack is obviously phishing. But Igor Homikov and Nir Goldschlager showed us that redirects can be used to bypass OAuth authentication. So that's why these things really matter, and why I feel they have a place in the OWASP top 10. Is these redirects can kind of screw up auth systems. So just if you're auditing an app, grep through for see other, move permanently, temporary, grep through for those, and simply do semantic analysis to find where people screw that up. I do want to jump back to A9 for a second. Something that I haven't seen in the Scala world that I have seen in many other worlds is like the Ruby world, for instance. In the Ruby world, there's lots of projects out there that automatically look at your gems, look for security updates for your gems, and then alert you on those security updates. As far as I know, there's nothing out there commonly used in the open source world and the Scala world that does a similar thing. Now, mind you, Scala world is a much smaller world than Ruby on Rails, but that would be something that would, in my opinion, make it a lot easier to just handle your dependencies and security vulnerabilities. So if you guys want to code that up. Thanks. Okay. So with that, we've kind of covered the OWASP top 10. We've touched on each one in the OWASP top 10, OWASP top 10, and given you a couple patterns. If you want to get like into the nitty gritty and you're going to be doing a pen test with this, get our white paper after this talk is done, whenever Black Hat puts it up, and we'll go through and get more fine-grained with the patterns. So you can just use it as kind of a cheat sheet when you're doing your assessments. Next thing, we'll just kind of wrap up with cool things about each one. So one cool thing that I really like in Play is they have a cryptographically sound equality comparison operator. So something that's been really hot the last year or so is mistakes when you're using equals for comparison when you're comparing secrets or authentication tokens. So it's been proven that you can do a ton of requests and find micro differences in the per character comparison and the underlying kind of like byte by byte memory comparisons. So Play was on that shit, and they said, all right, we're going to make a timing agnostic comparison. So that's just one random cool thing that I like about Play. One random cool thing that I like about Lift is the whole notion of sitemap. And it's like Spring Security's baked into your application. It's just integrated into your application. Sitemap is available for use, and I recommend everyone that's making a Lift app use sitemap. It's just everything you need for authorization checks, all the way to routing and what have you. Okay. So in general, covering Lift versus Play. Yes, question?
Oh, that was, yeah, that's
yeah.
for
Sorry,
Lift.
I did not put that. That's Lift. Sitemap is the feature of Lift. This crypto sound operator is in Play. All right. So in general, Lift versus Play, they're both pretty good. Compared to a lot of other web app frameworks in other languages, they give you a lot of really safe defaults. So they're pretty nice. You really have to go out of your way to shoot yourself in the foot to use them when you're using them. But they still do leave some room to shoot yourself in your foot. As we've seen, we just went through the OWASP top 10 and covered at least one gotcha in every one. One thing I would love to see is there's nothing for native Scala code that parses it and does a static analysis of it that lets you track control flows or data flows. Basically, all you're doing as a penetration tester right now is basic semantic analysis, grepping through, looking for patterns, and that's it. I would love to see a static analysis framework so that we can just write rules for it with a static code analyzer as opposed to just kind of grepping through here and there and hoping that we find everything. So when we audit apps, we love static code analysis. We're heavy users of commercial and open source static analysis tools. I feel that too many penetration testing firms are over there poking around and doing black box stuff, and it's just inefficient. You really need a good static code analyzer and the people that know how to use it behind it to be efficient and be comprehensive at penetration testing. So that is my main takeaway. Lift and Play, both pretty damn good. I wish they had a static analyzer. So that's another thing I want you guys to write. Thanks. Okay, so now to the code that we're dropping as part of this. Let's see how much time we have left. Any Black Hat people have a timer for us? No. All right, 5 minutes. Awesome. 2 demos and a bunch of other slides. 5 minutes. All right. Server-side request forgery. This is not in the OWASP top 10, but we're going to cover it basically. Oh man, the snake. I left the snake in there. Sorry. That was a joke. It was not supposed to be there. Okay. Server-side request forgery is a problem in Scala world as well, regardless of if you're using Play or Lift. Basically, what the issue here is user controllable input reaches an HTTP client call in your application. Right? So you go and your app is a client and requests something. The most typical use case here is you have a user profile pic and you want to give them a URL where they can just grab the user profile pic from somewhere else on the internet. Like right click, Facebook CDN, drop that into there, and your app just nicely grabs the URL, grabs the pic and puts it as part of their profile pic. So when you're doing that, what if I don't specify my Facebook profile pic? What if I specify an internal server like that has your Soto type repository that lives on 10.0.1.1? And maybe I use knowledge of the internal systems, or maybe I just brute force the address spaces, the 192, the 172, the 10 dot. I brute force all those address spaces, and I find where your internal things are. I can port scan them. I can do various attacks, proxy through, and things like that. So this is clearly a pretty bad thing. And I'll just share a funny little story. When I was signing up for the RSA conference this year, I was checking out, and they give you a PDF, and I'm looking at the checkout URL, and it's a URL in the URL, and I was like, wait a minute, they wouldn't be, so they were using an internal middle tier server to generate the receipts after you signed up for RSA conference, and then after they generated the receipts, they spat out the PDF through the web app layer, so they did an internal call. If you just change that URL to other internal things or things out on the internet, it was a straight SSRF. So I called RSA, the security conference, and told them, hey, you guys have the security vulnerability. They fixed it. They were very gracious about it. And I can't believe nobody else found that. Every single person that signed up for RSA looked at that URL and did not find that attack or did not tell RSA about it. So yeah, what we created was there's this guy, Finite, his handle. He created this cool library, SafeCurl. SafeCurl is an HTTP client library for wrapper library around curl for PHP. Now, we looked at that and we were like, that's great. Because all of our clients, all the time, we're trying to give them this general guidance of, well, you should look for 10 dot and 172 dot, and you should prevent DNS rebinding attacks and 302 redirect attacks against you guys through SSRF. And we're just giving like a pages of advice on how they should protect against this. But as security practitioners, that's horrible. You don't want defenders to give them 2 pages of advice on how to prevent something. You want to give them a library that they can call. So that's what we created for Scala. We created an anti-SSRF library, and it's modeled on Finite's SafeCurl. So we call it HTTP Client Scala Library for Preventing Server-Side Request Forgery, or THUFTHUA for short. So we're not good at naming things, so we'll just call it anti-SSRF flip. It's modeled on Finites, and the whole purpose of this is we just want to be able to give our clients, like, hey, use this. Don't try and implement this crap on your own. And this is something that I feel should be baked into the HTTP clients, not just in Scala, but in various other languages. You don't want to be vulnerable to SSRF. Build this protection into your HTTP client libraries. At the Play and Lift framework level, they may be able to do something like this. They may be able to bring that in and add it into the framework. I would love to see that. But that's generally kind of the concept. Yeah, so we're gonna release the code for this probably tomorrow. I'm really tired right now, so we'll get to it tomorrow. Just follow us on Twitter at Include Security, or just follow us on GitHub if you want that code, and we'll release that tomorrow. So Samuel here helped out with that code. The other piece of code, let's see how much time we got. All right, we're out of time. So very quickly, if anyone needs to go, I understand, but we'll just cover this in a couple minutes. We created this app called Blabber. So we were doing Scala assessments, and we just wanted to kind of have a hack me app where we could practice our attacks against Scala apps. So Blabber was written by one of our interns, Stuart, and it's basically a hack me app. It's a very simple Play framework app. And it's really good for testing out dynamic testing tools. You can use it for interviewing people, like, hey, can you hack this? If you can't, and this is a very, very basic application, and it is a very, very basic, obvious vulnerabilities. So it has at least one of each of the OWASP top 10 in it that we just covered. All the bad patterns that we just went over, they're all in there. And Blabber is, you can tell by the logo, it's a Twitter clone. So it's like a little micro blogging service. And we spent millions of dollars creating the logos, like the Heartbleed guys. Yeah. So what else? Okay. So yeah, if you're an expert, everything in this presentation and in Blabber is already, you already know all this stuff. But the way you might use it is, the way we do it is just kind of compete with your friends. So see if you can do a speed run and get all of the attacks and see how fast you can do it. If you can beat 13 minutes, write me. I'll give you a job. Yeah. And we'll also push that tomorrow. Just want whenever we get to it. So Blabber, please don't ever deploy that on the internet. It's just full of holes. But it's fun as a pen tester to just go through and look for these things and just get a little practice in a micro level. So when you get out there and you see these apps. Now, one big question I get from people when they saw this topic is, hey, is Scala getting hot? Who's using it right now? So there are big companies out there like Foursquare and LinkedIn use a lot of Scala. I believe Foursquare uses Lyft and
LinkedIn uses Play.
And LinkedIn uses Play. So there are big companies out there using this stuff. And it's getting more and more popular in the startup world. So we do a lot of work with startups. So we see all sorts of inside middle tier applications written in Go and Scala and things like that. And we're seeing more and more of it. So with these frameworks being as secure as they are, that's good. But with what we've shown you so far, hopefully you can find some of the gotchas. Here's some future areas to explore. More build issues. Would love to see static code analysis. Violation of type safety permissions. So here's a really cool concept. And you've seen this in PHP throughout the years, is type confusion, right? So somehow you can convince the app that one type is another type through how you structure the URL. Maybe it's an array and it looks like this, and while it's casting an int to something else, it screws up and now it thinks it's a different type. And through that, you can get past security boundaries. So further research that we'll be doing, and we highly encourage you guys to do, is looking for issues like that in the Scala runtime itself that can be exploited through these web frameworks. Also, another thing that's part of Scala is the framework Akka and the concept of futures, which is kind of like an asynchronous pattern where you say, all right, I have this variable foo, and foo doesn't exist yet. So let's say foo is a call to HTTP client library call. So as that request is happening, I've got that latency to go out on the web and pull that down and populate that variable foo. I can still process other things asynchronously. So that's what futures are about. With all these futures and Akka and everything, you're going to have synchronization issues. So we're going to be looking at more synchronization issues with these things. If you guys have any cool findings, patterns where people really screw up these things with Akka and futures, would love to hear about it. And I think with that, we're all done. So thank you for attending, and hopefully you learned just one thing about something.